Hello everyone, my name is Chloe. Today I will present my project on medium and high-rise construction methods adopted in Australia. This presentation focuses on two main parts, substructure construction and superstructure systems. This presentation is divided into two main stages. First is substructure, where I compare bottom-up and top-down construction methods. Second is superstructure, where I will analyze different slabs, including flat slab, waffle slab, brand beam, and rib slab. Finally, I will summarize the key findings and lessons learned. The basement construction is a critical stage in high-rise project. It directly affects project cost, risk, and construction time. The main factors include site conditions, soil type, and surrounding buildings. In Australia, two main methods are commonly used: bottom-up and top-down. This diagram shows the typical bottom-up systems. Firstly, a retaining wall is constructed to support the soil. Then, excavation is carried out in stages with temporary supports such as the steel struts. After reaching the final depths, the structure is built from the bottom upwards. This slide shows the typical construction sequence of the bottom-up method. As we can see from the diagram, the process is carried out in a step-by-step sequence. The step 1 is the retaining wall is installed before excavation begins. This wall is used to support the surrounding soil and prevent collapse. The step 2 is excavation starts to the first level and a steel strut is installed. This provides temporary lateral supports to maintain stability. The step 3 is excavation continues in stages, and more struts are added at different levels. This continues until the final depth is reached. The last step is the permanent structure is constructed from the bottom upwards, including the base slab and walls. At this stage, the temporary supports can be gradually removed. Overall, this method follows a sequential process, where excavation is completed before the main structure is built. These slides introduce the bottom-up construction, the site suitability. In terms of site suitability, this method is mainly used in open sites where there is enough space. It is also suitable for low-density areas where the impact on surrounding buildings is minimal. However, in soft soil conditions, careful monitoring is required due to the risk of the ground movement. The main advantage is that it is cost-effective because the method is simple and does not require complex systems. It is also widely used in the industry, so it is easier to manage. However, there are some important limitations. First, the process is sequential, so it takes a longer time to complete. Second, there is a higher risk of ground movement. Finally, it is relied heavily on temporary supports, which increases construction complexity. These slides introduce the top-down constructions. In construct, the top-down method integrates excavation and construction. Floor slabs are constructed early and act as permanent support. This reduces the need for temporary supports and improves structural stability. The construction starts with retaining walls, followed by the roof slab. Excavation continues the slab while new slabs are constructed progressively downward. This allows simultaneous construction of substructure and superstructure. The top-down method provides better control of ground movement. It is suitable for dense urban areas with limited space. It also improves project efficiency because construction can occur simultaneously. However, it is more complex and has higher initial cost. This table summarizes the key difference. The bottom-up is simpler and cheaper but slower. The top-down is faster and more stable but more complex and expensive. Therefore, the choice depends mainly on site conditions and the project constraint. In superstructure, slab systems plays a key role in load transfer. Loads are transferred from slabs to beams or directly to columns. The selection depends on span cost and architectural requirements. This slide shows the flat slab systems. As we can see from the diagram, the slab is directly supported by columns without beams. The job panel and the column capiculi are used to reduce punching shear around the column. This is important because the load is transferred directly to the column, which creates high stress connections. The main advantage is the flat soft, which makes it easier from MEP installations. It also allows faster construction due to simple formwork. However, the span capacity is limited, and punching shear is a key design issue. So overall, flat slab is a very efficient and commonly used system in high-rise buildings. This is the waffle slab systems. As shown in the diagram, it consists of the grid of ribs in two directions. The voids reduce the self-weight of the slab, while maintaining structural strength. The increased depth improves stiffness and reduces deflections. This system is suitable for long spans and large open spaces, such as car parks. However, it requires complex formwork and longer construction time, so the waffle slab provides high structural efficiency but with higher construction complex. This slide shows the brand beam and slab systems. The brand beam is a wide and shallow beam integrated with the slab. As shown here, the slab spans in one direction while the band beam distributes loads across the structure. Compared to the traditional beams, the soft is relatively flat. This system provides better deflection control than flat slab, while still maintaining a relatively simple construction process. However, this beams may still interferes with service compared to the flat slabs, so it is a balanced solution between structural performance and constructability. This is the ribbed slab systems. It consists of the parallel ribs that act as beams. The load is transferred in one direction to the supporting beams or columns. The thin slab on top distributes the load to the ribs. These systems allow longer spans and reduces material uses. However, it is less flexible than two-way systems like waffle slabs, so the ribbed slab is efficient for one-way span structures. This table compares all slab systems. The flat slab is best for simply and service integrations. The waffle slab is best for long spans. The brand beam provides a balance. The ribbed slab is efficient for one-way spanning, so therefore no system is universally best. It depends on project requirements. In conclusion, construction method selection depends on site conditions and project containers. Top-down is preferred in urban environment, while bottom-up is suitable for open sites. In superstructures, the slab systems must balance structural performance, cost, and constructabilities. Overall, engineers must evaluate multiple factors to select the most appropriate systems. Thanks for your listening. This is the reference